So right now, all we know for similar figures is that they have congruent angles and proportional sides. So just like last chapter, when we had side, 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 side angle, side, and stuff like that, we have three theorems to kind of act as shortcuts. And our first one is going to be AA, which stands for angle, angle. It's going to be our AA similarity postulate. So basically all we need for AA are two angles of one triangle that are congruent to two angles of another triangle. If this happens, then I know my figures are similar. So let's take a look at my triangles. I know that angle B is congruent to angle F because it says so. And I know that angle C is congruent to angle D because it says so. So I have an angle and an angle, so I have enough to use AA. So since my angles happen, since this happens, I know that ABC is similar to EFD. All right, if you notice, B and F are congruent, so they're in the same spot. C and E are congruent, so they're in the same spot. So if I can conclude that my triangles are similar, then I know that everything we learned on Tuesday also happens. So if my triangles are similar, I also know that my third angles are congruent, and I know that all of my corresponding sides are proportional. So since I have AA, so I'm not sure where that left off, but if we have similar triangles, so if I see that two angles are congruent, I know my triangles are similar, so I know all of this happens. So that's all we're going to do today. We're not really going to do proofs like last chapter. All we're going to do is look for two angles, and if that happens, then I know I can solve a proportion. So let's look at something that happens. First, I want to decide if my triangles are similar, and if they are, to write my similarity statement. So that's like triangle QRS is similar to triangle XYZ. So let's look at what we got. Alright, so here are my triangles that we're looking at. We're looking at triangle ABC and triangle CDE, and I want to know if they're similar. So the only thing we know right now is AA. So I'm going to look for two angles. The first angle I know is that angle A is congruent to angle E. I know that because that was given to me in my problem. The next thing I know are going to come from these two lines that form an X. If you remember, when I have an X, I have vertical angles. So I know that angle ACB is congruent to angle DCE, which are the ones I marked in red. And I know that because of my vertical angles congruence theorem. So if you notice here I got an angle, and here I got an angle, so I have enough to use AA. So I know that my triangles are similar, of course because of AA. And I'm going to make sure I write that correctly to where A and E are in the same spot, and my C's are in the same spot. Everything else will fall into place. Here's our second and last example. We're going to decide first if my triangles are similar. Then if that happens, I'm going to use similarity properties to set up a proportion to solve for X. Alright, so first I got to look for angles because the only thing I know right now is AA. So we're going to try and find AA. So the first thing I'm going to look at is my X. So here, let's see. So here I got the X again that we just had in our last example. So I'm going to look at angle ACB and angle DCE. Alright, and I know those are congruent because of my vertical angle congruence theorem. Alright, the next thing I have are parallel lines. If you remember, when I have parallel lines, I'm always going to draw them separately. I'm going to look for a transversal. Alright, when I do that, I end up having these parallel lines that I highlighted in pink right here. So I'm going to look for the angles that are my parallel lines that are also in my picture, and they happen to be angle B and angle C. I know those angles are congruent because they're alternate interior angles of parallel lines. So I have AA, so I know that my triangles are similar. Now that I know my triangles are similar, I know that all my sides are proportional, so I'm going to set up a proportion. Ooh. I guess I have an eraser. Let's see. All right, so let's set up a proportion. If you notice, I'm going to look for sides that look the same. So here, when I look at 20, it's in between my 2 arcs and my 1 arc. So I'm going to look for what side looks like that, and it happens to be my X. So here, 20 and X are corresponding. So I'm going to use that in my ratio. I also see that 24 and 48 are corresponding because this is just attached to my 1 arc and this is just attached to my 1 arc. I do also know that AB and DE are corresponding, but I don't know anything about them, so I don't really care about them. So this is my proportion that I have right now. 20 over X equals 24 over 48. I can go ahead and cross multiply now, but I want to make my life easier, not harder, so I'm going to simplify. I know 24 over 48 ends up simplifying to 1/2. Now I cross multiply. So I take, oops, that didn't work. So this is 2 times 20, and when I cross multiply here, oh, that gives me that 2 times 20, and then I get my 1 times my X. So when I simplify, we get 40 equals X, and I'm done. If I wanted to, I could ask you what my scale factor is right now. And just keep in mind, it's going to be what everything simplifies to. So we could do 24 over 48, simplify it, or we could do 2 over 20 and simplify it. So make sure you can do your scale factors, make sure you know how to set up proportions. The only difference between today and Tuesday is that today I'm not told my triangles are similar. I got to justify to myself that they are. Once that happens, look for your corresponding sides, set up a proportion, and then plug and chug. Just cross multiply and solve for your variable.